September 20th, 1943. The North Atlantic. Latitude 56 north, longitude 28 west. A British destroyer cuts through heavy swells at 14 knots, her bow throwing spray across the foredeck as she races toward a reported submarine contact. The sky is low and gray. Visibility is poor. The sea is running at force 5, maybe 6, rough enough to make every movement on deck treacherous, but not rough enough to abort the hunt. The crew is tense but confident. They have done this before. Their ship is fast, well armed, and crewed by veterans who have already killed U-boats. The captain stands at the bridge, binoculars pressed to his face, scanning the dark water for any sign of a periscope, a snorkel, an oil slick. Behind him, the ASDIC operator hunches over his console, headphones clamped tight, listening to the underwater world for the telltale echo of a submerged hull. Contact confirmed. Bearing 275. Range closing. The destroyer heels into a turn. The depth charge crews stand ready. This is the part of the war they understand. The deadly game of cat and mouse that has played out across the Atlantic for 4 years. Find the U-boat, pin it down, kill it before it kills you. Then, without warning, the stern of the ship erupts. The explosion is not where anyone expected it. Not forward, where a torpedo might strike broadside. Not amidships, where the magazines and fuel tanks make the most tempting target. The blast comes from directly astern, from below, a hammer blow that tears through the hull just beneath the propellers. The ship shudders violently. Men are thrown from their feet. The lights flicker and die. The steering fails. The aft compartments flood with shocking speed. Within seconds, the destroyer begins to settle by the stern, her screws still turning uselessly in the air as the sea pours in. Men are screaming. Damage control parties scramble through smoke-filled passageways. The captain orders emergency procedures, but he already knows. He can feel it in the way the deck tilts beneath his feet. His ship is dying. And he has no idea what hit them. There was no torpedo track, no wake cutting across the surface, no warning from the lookouts, no sonar contact suggesting a submarine in firing position. The weapon came from behind and below, from an impossible angle, as if it had chased them down, as if it had followed them, as if it had listened for them, as if it had thought. Because it had. What struck that destroyer was not a conventional torpedo. It was a new kind of weapon, one that did not need a U-boat commander to calculate angles and lead distances, one that did not travel in a straight line, one that found its own target, one that hunted by sound. The Germans called it the Zaunkönig, the wren, a small bird with a deceptively innocent name. The Allied codename would be Gnat, German Naval Acoustic Torpedo. NATO would later classify it as the T5, and in the autumn of 1943, it was the most terrifying development in submarine warfare since the torpedo itself. But this is not a story about German triumph. This is not a story about a wonder weapon that changed the war. This is a story about how the most sophisticated torpedo ever built, a precision-engineered marvel that represented the cutting edge of German acoustic technology, was rendered almost completely useless by 2 hollow steel pipes dragged through the water on a cable. And the fact that the Germans never solved that problem, never found a countermeasure, never reclaimed the advantage, tells you more about the nature of technological warfare than any engineering manual ever could. Because this is exactly the kind of story that disappears behind the headlines. The desperate gamble, the elegant solution, the billion Reichsmark humiliation that the official histories barely mention. The moment when German engineering genius met British practical improvisation, and genius lost. By the autumn of 1943, the Battle of the Atlantic had already turned against Germany, and the men who commanded the U-boat fleet knew it. The spring of that year had been catastrophic, not just bad, but existential. In May alone, 43 submarines were lost, 43 boats, 43 crews, nearly 2,000 men dead or captured in a single month. The casualty rate was so severe that Dönitz briefly considered withdrawing his submarines from the North Atlantic entirely. The Allies had cracked the Enigma codes, though the Germans did not know this with certainty. They had deployed long-range aircraft equipped with centimetric radar that could detect a surfaced U-boat from miles away. They had organized hunter-killer groups, dedicated escort carriers and fast destroyers, working together to find, fix, and destroy submarines. They had flooded the convoy routes with warships, closing the gaps where U-boats had once operated with impunity. And the wolf packs, the coordinated patrol lines that had once terrorized merchant shipping, were now being hunted themselves. Admiral Karl Dönitz, commander of the U-boat arm and soon to become Grand Admiral of the entire German Navy, faced a crisis that no tactical adjustment could fix. His boats were being destroyed faster than German shipyards could replace them. His trained crews were dying faster than training schools could produce new ones. The tonnage sunk per U-boat per patrol, the metric that mattered most, had collapsed. The tonnage war was lost. Britain was supposed to starve. Instead, Britain was building more ships. America was sending more convoys. The lifeline across the Atlantic was growing stronger, not weaker. And the worst part, the part that kept Dönitz awake at night, was that the escorts were winning. The destroyers, frigates, sloops, and corvettes that guarded the convoys had transformed from nuisances into executioners. They worked in coordinated groups, sharing sonar contacts and depth charge patterns. They used ASDIC, what the Americans called sonar, with increasing skill, tracking submerged U-boats through the thermoclines and density layers of the deep Atlantic. They dropped depth charges in precise patterns, bracketing their targets, forcing submarines deeper and deeper until the pressure hull groaned and the air turned foul. When a U-boat surfaced to escape or recharge its batteries, which it had to do because the submarines of 1943 still ran on diesel and electric motors, the aircraft were waiting. Liberators with Lee lights, Sunderlands with radar, Catalinas that could loiter for hours, watching, waiting. The escorts were killing U-boats at an unsustainable rate, and Dönitz knew that unless something changed dramatically, the submarine campaign was finished. That something was supposed to be the T5. The idea behind acoustic homing was simple in principle and fiendishly complex in execution. A conventional torpedo ran in a straight line. The U-boat commander had to calculate the target's speed, course, and distance, then set the gyroscope and depth mechanism, then fire at a point where the torpedo and the ship would intersect somewhere in the future. It was geometry and guesswork, complicated by wind, current, the target's movements, and the nerve-wracking delay between firing and impact. Against a slow, fat merchant ship steaming in a predictable line, this was manageable. An experienced commander could score hits reliably. Against a fast maneuvering destroyer, it was nearly impossible. Escorts were built for speed and agility. A destroyer could make 30 knots. It could turn sharply. It could accelerate and decelerate. A well-handled warship, alerted to a torpedo launch, could present its narrow bow or stern to the threat and let the weapon pass harmlessly by. The geometry that worked against merchants failed against warships. U-boat commanders hated attacking escorts because the risk was enormous and the probability of success was low. But the escorts had to be killed. They were the shield that protected the convoys. Remove the shield, and the merchants were defenseless. The logic was inescapable. What if the torpedo could steer itself? What if it could hear the target? What if, instead of calculating where the destroyer would be, the U-boat could simply fire in the general direction and let the weapon figure out the rest? This was the promise of acoustic homing. Every ship makes noise. The machinery makes noise. The hull makes noise. But the propellers make a very specific kind of noise. When a propeller spins at high speed, the blades churn through the water so violently that they create cavitation. Tiny bubbles of vacuum that form and collapse in milliseconds, producing a distinctive high-frequency sound. The faster the ship, the louder the cavitation. A destroyer at 14 knots was screaming its position into the water at frequencies that traveled for miles. The T5 was designed to listen for that scream. It carried a pair of hydrophones in its nose, set slightly apart, sensitive enough to detect propeller cavitation at several hundred meters. Behind the hydrophones sat an analog guidance system, vacuum tubes and relay switches, primitive by modern standards but revolutionary for 1943. This system compared the signal strength from each hydrophone continuously. If the target was to the left hydrophone received a stronger signal, and the guidance system deflected the rudder left. If the target drifted right, the torpedo followed. It was a feedback loop, a simple servo mechanism, but applied to a weapon that moved at 24 knots through black water. The T5 had a range of nearly 6,000 meters. It was optimized to home in on ships traveling between 10 and 18 knots. Precisely the speed range that convoy escorts used when hunting submarines or screening convoys. Too slow, and the cavitation signature was weak. Too fast, and the torpedo could not catch up. But in that golden window, the weapon was deadly accurate. And here was the crucial tactical advantage. The T5 was fired from behind. With a conventional torpedo, the U-boat had to get ahead of the target, calculate the intercept, and fire a spread across the predicted path. This meant exposing the submarine to detection, coming shallow enough to use the periscope, spending precious time on geometry while the escorts closed in. With the T5, none of that mattered. A U-boat commander could fire from the stern quarter, even from directly astern, and let the torpedo do the work. The weapon would acquire the propeller noise, turn toward it, and run down its prey like a hound chasing a rabbit. The Germans believed they had built the perfect escort killer. For a brief moment, they were right. The first operational deployment came in September 1943 against convoys ONS-18 and ON-202, two westbound convoys that merged at sea and found themselves surrounded by one of the largest wolf-pack concentrations of the war. The battle lasted nearly a week. Over 20 U-boats participated, and for the first time, they carried the T5. The results were shocking. HMS Lagan was hit first. The frigate was zigzagging at moderate speed, screening the convoy's flank, when the torpedo found her. The explosion struck directly beneath the stern, destroying the propellers and rudder, killing men in the aft compartments immediately. The ship lost way and began to founder. She did not sink immediately. Damage control parties fought for hours. But she was out of the fight, a crippled hulk that had to be towed to safety. Then HMCS St. Croix. The Canadian destroyer was an experienced convoy escort, veteran of dozens of Atlantic crossings. She was attacked while pursuing a sonar contact, focused entirely on the U-boat ahead of her, when a T5 fired from another submarine struck her stern. The explosion was catastrophic. The ship went down fast, taking most of her crew with her. Only 81 men survived from a complement of nearly 150. Then HMS Itchen. The frigate had picked up survivors from St. Croix and was attempting to withdraw when she too was struck by an acoustic torpedo. This time, the ship sank in minutes. The combined death toll was staggering. Nearly all the survivors from St. Croix died again, along with most of Itchen's crew. One officer and 2 ratings survived. Out of the combined crews of 2 ships, 3 men lived. The escorts were supposed to be the hunters. Now, they were being hunted. More ships were damaged in the following days. Torpedo after torpedo struck from unexpected angles, from impossible positions, from U-boats that the escorts had not even detected. The attacks seemed random, inexplicable, terrifying. Men who had served through the worst years of the Atlantic War said they had never experienced anything like it. The Allies were stunned. For a brief, terrifying window of perhaps 6 weeks, it looked like the entire tactical balance of the Atlantic convoy war had shifted. If U-boats could reliably kill escorts, then the screening forces would be depleted. The destroyers and frigates and corvettes that had made the Atlantic safe, or at least survivable, would be dead, and the convoys themselves would be exposed. The merchant ships, slow, unarmed, packed with fuel and food and ammunition, and tanks and aircraft, and everything else that Britain and the Allied armies needed to survive and fight. Without escorts, they were targets. Without escorts, the wolf packs could return to the slaughter of 1941. Britain's survival depended on those convoys. The invasion of Europe depended on those convoys. And suddenly, the warships protecting them were dying in a new and incomprehensible way. Naval intelligence scrambled to understand what was happening. Survivors were debriefed in hospitals and holding facilities. Wreckage was analyzed by naval architects and ordnance experts. Captured German documents, fragments recovered from sunk U-boats, interrogation reports from prisoners, decrypted signals were studied with desperate urgency. Within weeks, the Allies had confirmed their worst fear. The Germans had fielded a homing torpedo. The physics were not mysterious. British scientists had theorized about acoustic guidance for years. The Royal Navy had even experimented with similar concepts. But theory was one thing. A working weapon in operational use was something else entirely. The Germans had solved the engineering problems, the miniaturized hydrophones, the analog guidance circuits, the integration with a fast-running torpedo body, and had deployed the result in combat. Knowing what the T5 was did not mean knowing how to stop it. And every day that passed without a countermeasure meant more escorts sunk, more crews killed, more convoys exposed. 1. The first instinct was to try to outrun the weapon. If the T5 homed on propeller noise, then perhaps ships could reduce speed and quiet their signatures. Below 10 knots, cavitation dropped significantly. A slow-moving escort might be acoustically invisible, or at least quiet enough that a torpedo could not acquire a solid lock. But this was operationally catastrophic. Escorts needed speed. They needed speed to respond to contacts, to race toward a datum where a submarine had been spotted. They needed speed to close with a U-boat and hold contact while depth charges were prepared. They needed speed to screen the convoy's flanks and van, repositioning constantly to cover threats from multiple directions. They needed speed to survive, because a destroyer sitting dead in the water was a target for conventional torpedoes, gunfire, and any other weapon in the German arsenal. Asking escorts to creep through U-boat-infested waters at 8 knots was asking them to be useless. It was asking them to die a different kind of death. Slower, but just as certain. The second instinct was to try to jam the torpedo acoustically. If the T5 listened for propeller noise, perhaps ships could flood the water with sound and confuse the guidance system. Noise generators, underwater speakers, anything that might overwhelm the delicate hydrophones or create false targets. But this approach had limits. The T5's sensors were not listening for random noise. They were tuned to a specific frequency range, the cavitation signature of a ship's propellers at combat speed. Broadband noise might confuse a simple sensor, but the German engineers had built in some selectivity. Random static did not reliably deceive the weapon, and generating enough acoustic energy to jam a torpedo from hundreds of meters away required equipment that did not exist on convoy escorts. What the Allies needed was not jamming. They needed deception. They needed a decoy, something that sounded more like a propeller than the propeller itself. Something that would pull the torpedo away from the ship. Something loud, cheap, and deployable under combat conditions by exhausted crews on pitching decks in the middle of the North Atlantic. The answer came from British naval scientists working under enormous pressure, with incomplete information about the enemy weapon, and a deadline measured in weeks rather than years. And its simplicity was almost insulting. They called it the Foxer. The Foxer was not a sophisticated device. It was not electronic. It had no sensors, no computers, no guidance systems of its own. It did not require precision engineering or rare materials. It did not need skilled technicians to operate or maintain. It was, in essence, 2 metal pipes with holes drilled in them, connected by steel cable and towed behind the ship at a distance of roughly 150 to 200 meters. That was it. 2 pipes, some holes, a cable. As the ship moved forward at speed, the pipes were dragged through the turbulent wake. Water rushed through the holes. The turbulence caused the pipes to oscillate and vibrate. They rattled. They banged against each other. They created a continuous, chaotic cacophony of noise. Noise that was loud. Noise that was centered on exactly the frequency range that the T5's hydrophones were designed to detect. To the torpedo's sensors, the Foxer sounded like the loudest, most cavitation-heavy propeller in the entire ocean. It was irresistible. The T5 would acquire the Foxer, turn toward it, and run it down with the same relentless determination it would pursue a destroyer. The torpedo would close the range, arm its warhead, and detonate harmlessly in the ship's wake, 200 meters astern, destroying nothing but seawater and a pair of expendable pipes. The escort would feel the explosion. The crew would know they had been targeted, but the ship would survive. The men would survive, and the convoy would continue its journey. The Americans developed their own version almost simultaneously, called the FXR, an abbreviation whose meaning has been variously reported and whose precise origin hardly mattered to the sailors who used it. The operating principle was identical. Towed noisemakers that created acoustic signatures louder than the ships themselves. Both devices were rushed into production with wartime urgency. Machine shops fabricated pipes by the thousand. Supply chains distributed them to naval bases across Britain and North America. Training officers demonstrated deployment techniques to exhausted escort crews. Within weeks of the first T5 attacks, Foxers were being towed behind destroyers, frigates, and corvettes throughout the convoy routes. The cost of a Foxer was negligible. A few pounds of steel, some cable, a few hours of labor from a machinist who did not need to understand acoustics or electronics, or anything more complicated than a drill press. The cost of a T5 was enormous. Precision machined components, delicate acoustic sensors, complex analog guidance circuits, vacuum tubes that could fail under shock or temperature changes, a dedicated production line at a time when German industry was struggling to produce enough conventional torpedoes, training programs for U-boat crews on the weapon's capabilities and limitations. The Germans had spent years of research and millions of Reichsmarks developing what they believed was the perfect weapon. The British neutralized it with scrap metal and physics. The effect was immediate and devastating for the U-boats. As Foxers were deployed across the escort fleet in late 1943 and early 1944, the T5's effectiveness collapsed. The statistics told the story with brutal clarity. In the first weeks of deployment, before the Allies understood the weapon or fielded countermeasures, the T5 had achieved a hit rate that terrified naval planners. After the Foxer, that rate plummeted to single digits. Torpedo after torpedo homed on the decoy instead of the ship. U-boat commanders reported successful attacks. They heard the detonations, felt the shockwave through the hull, logged their kills with confidence, and watched nothing sink. They surfaced after their attacks, expecting to see debris and survivors, and found only empty ocean. The weapon that was supposed to save the submarine war had become a source of bitter frustration and operational confusion. German naval intelligence struggled to understand what was happening. Reports from U-boat commanders were contradictory. Some claimed definite kills. Others reported torpedoes that seemed to malfunction, circling endlessly or detonating against nothing visible. The patterns made no sense until captured Allied sailors and recovered debris revealed the truth. The Germans knew about the Foxer by early 1944, and they began frantically trying to adapt. Engineers adjusted the frequency sensitivity of the hydrophones, hoping to tune out the Foxer's signature while remaining sensitive to propeller cavitation. But the signatures overlapped almost perfectly. That was the entire point. The Foxer was designed to mimic what the torpedo was hunting. They experimented with different homing algorithms. Perhaps the torpedo could be programmed to distinguish between a consistent, complex propeller signature and a chaotic, simple noisemaker. But the analog guidance systems of 1943 did not have the processing power for sophisticated signal analysis. The T5 had 2 hydrophones and a handful of vacuum tubes. It could steer toward noise. It could not evaluate the quality of that noise. They attempted to add pattern recognition to teach the torpedo that targets should grow louder from the sides and quieter from directly ahead as the weapon closed in. But this made the guidance system more complex, more fragile, more prone to failure under the shock and vibration of combat. Nothing worked. The problem was fundamental. The Foxer exploited the core assumption of acoustic homing, that propeller noise was a reliable signature of a ship. By creating a signature that was louder and more consistent than any propeller, the Foxer turned the torpedo's greatest strength into its fatal weakness. To ignore the decoy, the torpedo would have to ignore the very thing it was designed to detect. There was no software update, no hardware tweak, no clever redesign. The acoustic homing principle itself had been exploited at its foundation. And the Germans never found a countermeasure. Not in 1943. Not in 1944. Not for the remainder of the war. The T5 continued to be produced and deployed because there was nothing better to deploy. U-boat commanders continued to fire them because the alternative was to attack escorts with conventional torpedoes, straight-running weapons that a competent destroyer captain could evade. But the wonder weapon was dead, killed by 2 steel pipes. This failure was not merely technical, it was strategic. The T5 had been positioned within the German naval hierarchy as the weapon that would restore Germany's dominance in the Atlantic. Dönitz had staked credibility on it, with Hitler, with the naval staff, with the submarine crews, who needed something to believe in after the disasters of Black May. Production resources had been allocated, training programs had been revised, tactics had been built around the T5's capabilities. The entire operational concept of the late war U-boat campaign assumed that escorts could be killed. When the weapon failed, there was no backup plan. There was no T6 with countermeasure capabilities. There was no alternative guidance system ready for production. The Germans had bet heavily on acoustic homing, and when that bet failed, they had nothing to fall back on but the same conventional torpedoes that had been failing against maneuvering escorts for years. This was the strategic cost of technological overconfidence. The T5 was sophisticated. It was clever. It represented genuine engineering achievement. But it was also narrow, optimized for a single mission, dependent on a single principle, vulnerable to a single countermeasure. When that countermeasure appeared, the entire investment was nullified. The U-boat fleet continued to deploy T5s because there was nothing else to deploy. Commanders continued to fire them at escorts, knowing the hit rate was dismal, because the alternative was not to attack escorts at all. And that meant abandoning the core mission of submarine warfare, protecting the attack boats while they went after merchants, then destroying the escorts that controlled the surface. The psychological effect on U-boat crews was corrosive. These men had been told the wonder weapon would turn the tide. Their officers had briefed them on the T5's capabilities with something approaching enthusiasm, a rare commodity in the U-boat fleet of late 1943. They had believed, or tried to believe, that the mathematics of the Atlantic War could be reversed. Instead, they watched their torpedoes detonate uselessly in the wakes of fleeing destroyers. They heard the explosions and felt the hope, then surfaced to see nothing sinking. They realized, slowly and bitterly, that the enemy had solved the problem. Again. The Allies always seemed to solve the problems. The radar, the Hedgehog, the escort carriers, the code breaking, and now the Foxer. Every German innovation was met with a counter-innovation. Every advantage eroded. Every new weapon was understood, analyzed, and neutralized faster than the next weapon could be developed. And the T5 was supposed to cut that lifeline. Instead, it became another symbol of failure. There is a deeper lesson in this story, and it has nothing to do with metallurgy or acoustics. The T5 represented a particular theory of warfare, the belief that technological sophistication can overcome numerical and tactical disadvantages, that a clever enough weapon can substitute for strategic position, that engineering can outpace adaptation. It is a seductive belief, and in certain narrow circumstances, it is even true. Superior technology matters. But technology does not exist in isolation. Every weapon creates a countermeasure. Every innovation invites a response. And the side that adapts faster, not the side that engineers deeper, often wins. The British response to the T5 was not more sophisticated than the German weapon. It was simpler, it was cheaper, it was developed faster, and it was devastatingly effective precisely because it attacked the assumption behind the weapon rather than the weapon itself. The Germans assumed that propeller noise was an unavoidable signature. The British gave them a louder signature to chase. The Germans assumed that acoustic homing was inherently difficult to deceive. The British made deception trivially easy. The Germans assumed that a complex guidance system was a strength. The British turned it into a vulnerability. This is the paradox of the technological arms race. The more sophisticated the weapon, the more specific its dependencies, and the more brittle it becomes when those dependencies are exploited. A simple weapon has few assumptions built into it. A complex weapon works only when all its assumptions hold true. Violate one assumption, and the entire system can fail. The Foxer was not a perfect solution. It had real costs. The device created enormous amounts of noise. That was its whole purpose. But that noise drowned out the ship's own sonar. An escort towing a Foxer could not use ASDIC effectively. The acoustic environment became so chaotic that submarine contacts were lost. This meant that ships had to choose: hunt the U-boat or defend against its torpedoes. The tactical flexibility that made escorts so deadly was compromised. A destroyer towing a Foxer was blind. A destroyer not towing a Foxer was vulnerable. The Foxer wore out too. The constant battering degraded the pipes quickly. Ships had to carry multiple sets and replace them during patrols. Deployment was dangerous. Men worked on exposed decks in rough weather, in the middle of U-boat attacks. But these were manageable problems. They were costs, not failures. And compared to the cost of losing destroyers, compared to the cost of losing crews, losing ships, losing the convoy, they were trivial. The calculus was simple. Tow the pipes and lose your sonar. Don't tow the pipes and lose your ship. The U-boat war did not end with the Foxer, but the T5 threat was contained. Escorts continued to operate, convoys continued to sail, and Germany's last great hope for a submarine renaissance died not in a pitched battle, but in an engineering office, when the scientists admitted that they could not fix the problem. By 1945, the U-boat fleet was a shattered force. Over 700 submarines were lost during the war. Roughly 30,000 German submariners died, out of a total service of approximately 40,000. The casualty rate approached 75%. No other branch of any military service in the Second World War suffered losses on that scale. The causes of that destruction were many: air power, radar, signals intelligence, the industrial might of America, the courage of merchant seamen, the skill of escort commanders. The T5 was not the direct cause of that defeat, but it was a symbol of something essential about Germany's approach to the war: the belief that a miracle weapon could reverse strategic reality. The V-weapons, the jet fighters, the Tiger tanks. Again and again, German planners invested enormous resources in sophisticated systems that promised to change everything. And again, those systems arrived too late, in too few numbers, or with fatal vulnerabilities already built in. The T5 was perhaps the purest example, a weapon that worked exactly as designed, and failed anyway, because the enemy found a simpler solution faster. Today, if you visit certain naval museums, you might find a Foxer on display. It does not look like much. A length of pipe, some cable, a few drilled holes, corroded now perhaps with age and salt. But that humble object changed the course of the Atlantic War. It kept destroyers alive. It protected the convoys that fed Britain, that armed the RAF, that built the stockpiles for Overlord. It neutralized a weapon that could have killed thousands more sailors. And the men who designed it did so in weeks, under pressure, with incomplete information. They were not trying to build the best decoy possible. They were trying to build a decoy that worked right now. They succeeded through brutal practicality, through ruthless simplification. The Germans, with all their engineering prowess, never found an answer. There is one final irony. After the war, acoustic homing torpedoes became standard equipment in every major navy. Modern torpedoes use acoustic guidance systems descended directly from the T5, far more sophisticated now, with digital signal processing and countermeasure capabilities. The technology worked. The T5 was not a failure of engineering. It was a failure of context. But the lesson of the Foxer endures in every naval planning office, every defense acquisition program, every debate about smart weapons, and the future of guided munitions. Every guidance system has assumptions. Every sensor has limits. Every smart weapon is only as smart as its ability to distinguish signal from noise. And an adversary who understands the system can feed it noise. Sometimes the answer to $1 million weapon is not a $2 million defense. Sometimes it is two steel pipes dragged through the water, banging together in the dark. Ooh. The Germans called their torpedo the Zaunkönig, the wren, a small bird, a clever name for a clever weapon. But in the end, the clever weapon chased a decoy. And somewhere on the seabed of the Atlantic, rusting now beneath miles of cold ocean, lie the fragments of T5s that hit nothing, defeated by junk, by noise, by the simple cunning of an enemy who understood that the most impressive weapon in the world is useless if it can be fooled. The convoys kept coming, and the wrens chased ghosts.